All right. So hello everyone. Again, apologies I cannot be there with you in person. You should hopefully be seated by now and have something down for your do now. If not, take about 4 minutes and make sure you get something down for these 4 questions. Again, you're gonna have 4 minutes silent and solo for this do now. Go ahead and begin. You can go ahead and pause the video here. All right, and bringing it back together, we're gonna go over number 1 and number 2. So looking at number 1, we want to graph 2x minus y is equal to 5. And as we saw yesterday, I need to kind of rewrite this so that I can make some sense of it when I'm actually trying to graph it. So I'm actually going to just go ahead and subtract 2x from both sides of my equation here, which is going to leave me with a negative y equal to a negative 2x plus 5. Now I need to get rid of this negative. And so in order to do that, I'm actually just going to multiply both sides by negative 1. And so remember, what that's really going to do on our right-hand side here, we're going to have this distribution, and so we need to make sure that we're distributing this negative to both terms inside the parentheses. Now, remember way back to when we first did distribution, and we first talked about distributing our negative, we need to make sure that every single sign in here is changing when we're distributing this negative in. So we're going to have on our left here, this negative is going to cancel with this negative to give us a positive y, and remember that's exactly what we want, that's by design. And on our right here, when we multiply a negative 2x times a negative 1, we're going to have a positive 2x. Remember, these signs are just changing. And then positive 5 times a negative 1 is going to be a negative 5. And so here, we have our line moved from standard form down into slope-intercept form. And so now we can easily see how we should be graphing this. I know that right away, hey, my slope is 2. And my y-intercept is going to be, remember, we should always write this as a point, 0, negative 5. So that's exactly what I'm going to do. I'm going to come over here. I'm going to find 0, 5, boom, right there. That's my first point. Now remember that 2 is the same thing as 2 over 1. So when we're looking at it graphically, this might help to see just a little bit, because then again, I have my rise right here over my run. So I'm going to go up 2 and over 1, and right here, 1, negative 3 is going to be my next point. Same thing, I'm going to go up 2 over to 1, so I'm going to have 2, negative 1. And I'm going to do it one more time. I'm going to go up 2 and over 1 for a 3, positive 1. These 4 points are going to be all I need to make this line. Apologies, as this is not going to be the straightest of lines. However, there we have it. That's going to be what this looks like. Now moving on to number 2. We want to graph y minus 3 is equal to 1/2 x plus 4. Now, this should hopefully look very much like point slope form. That's because it's exactly what it is. And so remember that the general form of point slope looks like this. We have y minus y1 is equal to m times x minus x1. And so we have our point here, and we have our slope. So I'm going to use those and take them right from this problem. So I have this slope right here. So I know that my m is 1/2. And then I'm going to build my point based off of this value here and this value here. And so over here, my y1 is going to be a positive 3. Perfect. That's nice and easy. That falls very nicely. However, notice that we have this positive here, and really we have a negative in our general form. So we know that this x1 value is going to be a negative value. So because this sign is switched, we have to remember that this is actually going to be a negative coordinate point here. So my x1 is actually going to be a negative 4. So my point is actually going to be a negative 4, 3. And so same way that I would use my y-intercept as a point and then use my slope to build off of, I'm going to use my one point here that they gave me and my slope, and I'm going to go ahead and build this line. So I'm going to have that negative 4. We're going to go down this way. And then positive 3, 1, 2, and 3 is going to put me here. And from here, again, I have my rise, which is 1, and my run, which is 2. So I'm going up 1 and over 2 to a negative 2, 4, and that's my second point. And I can do this again to 0, 5. So we know that if we were to rewrite this into slope-intercept form, we would have a plus 5. And I can do it one more time, all the way over to 2, 6. And again, these 4 dots are going to be enough to construct my line. We go through all of them. And there we have it. Take a second to get these down. Hopefully you were able to pick apart the pieces of this one here. And if you're wondering about 3 and 4, it's going to be that same process where you're really just looking to pick apart these equations to see exactly what we need to graph and then going from there. So again, take a minute and get this down. All right, and then go ahead and turn to what's hopefully in your packets. You should have this page here, example 1. You should have example 1 class notes. Take 30 seconds, find that page, and make sure that everybody's there. You can pause the video if you need to. All right. Important note as well, if you don't have this, we're going to go ahead and we're going to write with me in your notebooks. So if you don't have this page, go ahead and pull out notebooks. Again, take about another minute and 30 seconds. Make sure we have everything out. Make sure today's date is at the top if it is in your notebook. Go ahead and pause the video and make sure everyone has it out. All right, so diving into this here, we have that Maria and Genesis are best friends who always walk home together after school. Today, Genesis had debate practice after school and Maria had track practice. Maria is currently on 3rd Street, where track and field is, and walks home at a pace of 1 block every 5 minutes. Genesis finally finished with practice at school, which is out on 5th Street, and begins walking at a pace of 2 blocks every 10 minutes. Now, there's a lot of information going on here. Let's read A and see what we have to do, and then make sure that we can kind of correctly go back through this and annotate and pick this apart. So for A, we want to write an equation that models Genesis's path home, where y represents the blocks, y represents the block she is on, and x represents the time in minutes. Okay, so perfect. They have already defined exactly what our variables are going to be. That helps us out. And so when we're looking at Genesis, we're going to actually go through and highlight what information is important to her. So I have a lot about Maria here, but then we have here, so here she is. She finished practice at school, and she's currently on 5th Street. And she walks at a pace of 2 blocks every 10 minutes. Well, okay. So I know that if I'm counting blocks and where she is, I know that she's going 2 blocks every 10 minutes. So I know that my slope, I'm looking at 2 blocks every 10 minutes. Because remember, this is my change in y, it's 2 blocks, and my time is 10 minutes. So this is going to come down to, after we reduce, is going to be 1/5. So my slope is 1/5. And I also know that she's on 5th Street here. So this 5th Street's actually going to represent my y-intercept. Because remember that if she hasn't started walking yet, that's where she is. She's on 5th Street. So if I were to write these both into my equation, I'm going to know that my b value is going to be 5. And I have my slope, so I can very nicely just go ahead and write this in slope-intercept form as y is equal to 1/5 x plus 5. Perfect. So now for question B, we want to write an equation that models the path Maria is taking, where y represents the block she is on and x represents the time. Perfect. So we're actually just using the same variables for the same representations, which works beautifully. And I'm going to go ahead now and do the same thing we did for Genesis, but I'm going to do the same with Maria. I'm going to use a different color so it's a little bit easier for us to see here. So she's on 3rd Street, and she walks a pace of 1 block every 5 minutes. All right. So again, her slope, I know that her slope is going to be 1/5. Now I can't reduce that, so it has to stay as is. And I know that she's on 3rd Street. So I know that my lovely b value here is going to be 3, because that is her initial starting point. And now from here, just like we did above, now that I have these two pieces, quickly going to write my equation. I'm going to have 1 over 5x plus 3. So looking at C, Maria believes that she is walking at a pace such that she will catch up to Genesis in 10 minutes. Will she catch up? Provide evidence. If you need to use this graph here, or again, if you don't have this, if you want to try and graph this in your notebook and see what it looks like, if that helps you, absolutely go for it. But using what we have, whether you've written it down or you have this sheet, take a look at letter C. Try this out for about 1 minute and 30 seconds, silent and solo. Go ahead and begin. You can go ahead and pause the video here. All right, so looking at C, hopefully you have something down. If you don't, that's okay. Just go ahead and follow along. So, again, Marie believes that she is walking at a pace such that she will catch up to Genesis in 10 minutes. So what we're really looking at here is we're looking at both of our equations. And so remember that Genesis, she's going to be on our left. Maria is going to be over here on our right. Let's split them down the middle-ish. So Genesis, in 10 minutes, let's see where she's going to be. So I'm going to substitute that 10 in for x. Because really what we should be having is that if they have in fact caught up and they're meeting, they should be at the same exact point. So when we plug this 10 in for our x, what we should be finding is that for both of these, they should be equal. Because they should be in the same spot or on the same block. So I'm going to have 1/5 times 10 plus 5. 1/5 times 10, or 10 divided by 5, is going to give us 2. Still plus 5, and so that we know that our y is going to be 7. So we know that Genesis in 10 minutes is going to be on 7th Street. That's where she's going to be. That's what this 7 is really saying. Over here, for Maria, we're going to do that same thing. We're going to take that y is equal to 1 over 5. We're going to multiply it by 10 plus 3. So again, same math here. We're going to do 10 divided by 5, still going to give us 2, plus 3, because remember that 3 is our 3rd street for our starting point. And we have 5. And so notice, so I think we can all agree that 7 is definitely not equal to 5. So I want you to go ahead, take about 30 seconds, turn and talk with someone close to you, and see, what does this mean? Why are these not equal if this is what we're expecting? Go ahead and start. All right, you should have about 10 more seconds. All right, and we're gonna bring it back. And so, hopefully while looking at this, one of the things that we realize, and we've looked at, is our slopes here. And if we take a look, both of them are walking at the same rate, right? They're both walking that 1 block every 5 minutes. For Genesis, it's named ever so slightly different, where it's 2 blocks every 10 minutes. But again, we know that we can actually reduce that fraction down, and it's the same speed as 1 block every 5 minutes. So these two are walking at the same exact rate, but they're starting in different points. And so hopefully there were a few light bulb moments where you saw that, hey, this is 1/5 and this is also 1/5. So instinctively we should know that these are never going to meet. But more specifically, if we were to use this graph and look at these graphically, we should be noticing something pretty quickly, in that they should, and this is not exact, so I apologize, but looking at this, they have the same slopes but different starting points. So we should notice, or hopefully remember, from a few weeks ago when we first defined them, we should see that these are actually going to be parallel lines. These are going to be lines that are never going to touch because they're starting in different spots, but they're increasing at the same exact rate, which means that these two are never going to catch up with each other. And so today we're actually going to take a look and practice a little bit more with parallel and perpendicular lines and what that means and how we quickly identify those slopes. And so before we do that, we actually want to quickly stamp one thing. If you have room at the bottom of your paper, that's fantastic. If you want to put this in your notebook, please take the time and make sure that's in there. But we're going to stamp really quick. And I know we've said it before, but parallel lines, when we're looking specifically at their slopes, slope 1 is going to be equal to slope 2. Just like we saw here, slope 1 is always going to be equal to slope 2. That's how we know we have parallel lines. And similarly, when we have perpendicular lines, it's going to actually look a little bit different. So remember, we said before that they're opposite reciprocals. And mathematically, what that's really going to look like is that's really saying that we're going to have that if m1 is our first slope, the m1 is actually going to be equal to a negative 1 over m1. Apologies. If m2 is our second slope, m2 is actually going to be negative 1 over m1. And so really, again, what this is saying here is, remember, this is that negative reciprocal that we've talked about before. This is just how we're going to show that mathematically. So that the slope of our second line, of our perpendicular line, is always going to be a negative of 1 over our first slope. So make sure you have this down. Make sure you have all of this down. I'm going to scroll back up just in case. And once you have that down, we're actually going to move to problem set A. So take 30 seconds, make sure you have this all down, go ahead and pause the video, and then once everybody's together, we can continue. All right, perfect. So we all have this down. So we're going to actually glance over example 2. So if that's in there, we're going to go ahead and skip that. And we're going to move to problem set A. Now in problem set A, I actually only want us focused on the first 2 questions. Now I know question 2 has a few different parts, but I only want us focused on these 2 here. So for problem set A, we're going to do 1 and all of 2. Take about 6 minutes. Hopefully as we get the swing of these, we should kind of see exactly what's going on. So again, take 6 minutes for 1 and 2. Work silent and solo. Please begin. You can go ahead and pause the video here. All right, so bringing it back. Quickly going over 1, we have that y is equal to 3x plus 7 and y is equal to negative 3x plus 10. Your friend states that these 2 lines that the 2 lines shown above are parallel. How do you respond in y? Well, if we look back in our notes, we know that in order for these to be parallel, I know that m1 is going to have to equal m2. And so I should pretty quickly be able to break this down, right? Slope-intercept form here. This is my m, and this is my m. And so what I'm looking at here, and what I'm asking, is 3 in fact equal to negative 3? And if you're looking at this, you should hopefully see really quick, hey, like, no, it's not. These 2 are not equal, which means that, very simply, these are not parallel. So how would we respond? We would say they are not parallel. And coming down to number 2. Now for number 2, we want to write an equation of a line parallel to each of the following. So I'm going to have some examples of my own. What we're really looking for here is our slope. You can have different y-intercept values or different point values. That's okay. The heart of the problem here is making sure that we have the same slope on each of these. So again, I know that my starting slope is 1/2 here. Very easy to pick out. So I know that as long as I write a line that has a slope of 1/2, it's going to be parallel. So I could have literally any equation here, whether it be point slope or slope intercept. I'm going to keep it as slope intercept just because it's a little bit easier to see and a little bit faster, I think. So I'm going to have that y is equal to 1/2 x plus 2. Again, the only thing I'm looking at here is this slope value. For this 2, or this positive 2, where I have positive 2, you can have literally any other number there as long as it's not -5. Because remember that if it is in fact -5, we actually haven't written a line that's parallel, we've just rewritten the same line. And so now moving down to b, again, hey, I have this 4 right here. I know this is point slope. I know this is where my slope lives in this equation. I know that my slope is going to be 4. So I know that my slope moving forward needs to be 4. Now, I'm actually going to keep the same form here, and there's a reason for that. So up here, it was really easy to see that these are going to be different lines by using slope-intercept. However, I need to be careful, because if I use slope-intercept, there's a small but very real chance that even through just putting a random number out here, like we did in in part A, we'd have to make sure that this line actually isn't equal to it by solving this equation that we have in front of us and writing that in slope-intercept form. And so in order to just avoid all of that hassle, I'm just going to keep it in point slope form. So I know that my slope has to be 4. Awesome. I'm going to have that y plus 1 is equal to 4 times x minus 2. And again, that's it. That's my line. I don't have to go further than that. Moving down here to C, we do have to do a little bit of work down here. And so I'm going to quickly add x to both sides of this equation and have that 3y is equal to x plus 9. I'm going to multiply both sides by 1/3. This is going to give me that y is equal to 1/3 x. Because remember, we're bringing this to everything inside those parentheses. Plus 1/3 of 9 is going to give me 1/3 of 9 is going to give me a 3. So I'm going to have that y is equal to 1/3 x plus 3. So the slope in my original equation is now here. And the m is equal to 1/3. And so my parallel line is going to be 1/3x minus 2. And again, I know what the y-intercept is right here. So again, I can write literally any number here as long as it's not +3. If you had finished those, absolutely fantastic. If you needed a little bit of help, that is okay. But make sure you have everything here down. All right. Now that we have those down, we're actually going to move to problem set B. Now for problem set B, same thing. We're actually going to look at number 1 and number 2 again. Again, we're going to look at number 1 and number 2. Go ahead and work on this with whoever is next to you. Again, 1 and 2. Hopefully, these should be pretty quick. So for both of these, I'm going to say that you're going to have 4 minutes. Again, feel free to work with that partner, but when that 4 minutes is up, we're going to quickly go over these. Go ahead and begin. All right. So hopefully you and your partners got pretty far and got through these 2 questions. So we're going to start with number 1. And we're actually only going to go over number 1 so that you have time for your exit ticket. So in number 1, we're looking at our y equals -2x minus 1 and y equal to -1/2 x plus 2, parallel, perpendicular, or either. Well, again, these have to do entirely with their slopes. So let's start with parallel. Let's see if they're parallel. Remember that for parallel, we're going to remind ourselves that m1 should equal m2. So my first slope is -2, and my second slope is a -1/2. Definitely aren't equal, so nope, I know this is absolutely not parallel. So if m1, because now I'm going to look at perpendicular, so if m1 is equal to -2, then if it's perpendicular, that means that m2 should be equal to -1 over a -2. Now this is where we're going to have to really make sure that we're careful with our negatives and kind of make sure we know exactly what's going on here. Remember that when we have the double negative like this, they're actually going to cancel out. And so m2 is actually going to be equal to 1 over 2. But that's not the case, right? Because we have a negative 1 over 2 for m2. We don't have a positive. So it means that they're not perpendicular either. So really when we're looking at these two lines, we know, hey, they're neither. They are neither parallel nor perpendicular because their slopes are neither equal nor are they negative reciprocals. Because again, if they were negative reciprocals, this is what m2 would have to be, and that's just not what we see here. All right. So go ahead and turn to your exit ticket. You're going to have until the end of class to work on your exit ticket. You do have homework at the back of this packet. It should be, I believe, this part here. But you do have 1 page of homework on the back of this packet. But for now, focus on the exit ticket. Make sure you get through it. Do as much as you can. I know there's a lot here. You have until the end of class. Silent and solo, please begin.